Hello everybody. Can you please put a thumbs up in the chat box if I am audible and if my screen is visible? Hello everybody and welcome to this introductory Kotlin webinar. I am Vandit Vasa and a member of ISTE-VIT. So without any further ado, let's get started. So what is Kotlin? Well, Kotlin is a modern replacement for Java which is developed by JetBrains in 2016. As Java was developed in the 90s and Kotlin in recent times, many new technologies were developed in those 20 years and are implemented in Kotlin with all the features of Java. So what are the features of Kotlin? Kotlin is a statically typed language, that is, the variable types are explicitly declared and thus are determined at compile time. Kotlin is also 100% interpolable with Java, which means that we can use both Kotlin and Java code in the same project. You can transcompile your Kotlin code to JavaScript code. That way, even your Kotlin code can run explicitly on the browsers. In Kotlin, you cannot get a null pointer exception implicitly. Kotlin compiler by default doesn't allow any types to have a value of null at the compile time. So how is Kotlin better than Java? Well, Kotlin is a very concise language which reduces the code that developers have to write, and in turn it reduces the number of errors that occur. Kotlin has extension functions which allows the developers to extend the functionality of classes without necessarily having to inherit the parent class. Whereas in Java, one must need to create a new class and inherit the parent class in order to use its functions. So why is Kotlin the primary language for Android? Well, the amount of boilerplate code reduces with Kotlin. For example, Java needs a constructor, getter, setter, toString, etc. to store the data. On the other hand, Kotlin provides a more straightforward way to create classes to hold the data. The compiler will auto-generate the constructor and the getters and setters methods for several fields and variables. The main reason for the Kotlin being a primary language is coroutines support. For background tasks in Android, Java enables the creation of multiple background threads when handling lengthy operations. The downside is that managing multiple threads is a complex task that may lead to more errors in the code. Similarly, Kotlin also provides the capability to create multiple threads. Nonetheless, it introduces a better and more straightforward solution known as coroutines. This brings us to the question, what are coroutines? Well, coroutines allow the developer to write code, suspend the execution and later resume it again. This enables non-blocking asynchronous code that seems synchronous. Hence, instead of creating multiple threads that the developer must handle later, coroutines avoid having too many threads. Plus, they can be clearer and more concise than Java's solution. Let's take an example. Let's say if you want to print something after 1 second has passed. In Java, you need to create a thread. For that, inside a thread, you have to create a runnable, and inside that runnable, you need to create a try block, because the runnable can throw an interrupted exception if you call the sleep method in there. And after that, you can print something out. Whereas in Kotlin, you just have to launch a coroutine and write only 3 lines of code that does exactly the same thing. So now let's get into the basic syntax of Kotlin. So Kotlin is usually defined in packages. The package specification is optional. If you don't specify a package in the source file, its content goes directly to the default package. So like many other languages, Kotlin's entry point is the main function. Println writes the line to the standard output. It is imported implicitly. Also note that semicolons are optional. Now let's get into variables. There are 2 types of variables in Kotlin. The first one is var. Var variables are mutable variables, which means it can be modified after initializing. And the second one is val variables. It means that it cannot be modified after initializing. In the as we saw in the previous slide, that while declaring the variable, here you can see that while declaring the variable, if we assign a value to it, we do not need to specify the data type, and the Kotlin's compiler is smart enough to figure out the data type. But here you can see that while declaring the variable, we are not initializing it. So we will have to provide a data type. Now we come to strings. Strings in Kotlin are the same as in Java, but we can also treat strings as arrays. Here in this example, you can see that we can even access every single character of our string using the character indices, which means that we can make that string as a character array. Well, strings are also objects, so that all the dot operators like dot length can also be used on the strings. One of the most common pitfalls in many programming languages, including Java, is that accessing a member of null reference will result in a null reference exception. In Java, this would be equivalent to a null pointer exception. This is known as a $1 billion mistake. In Kotlin, the type system distinguishes between references that can hold null and those that cannot. For example, a regular variable of the type string cannot hold null. Well, let's see the null safety with an example. Let's remove this and create a variable of type string, and let's give a dummy value to it. Now let's try and set it to null. Now if we run this code, this should throw an exception. As you can see that it is throwing a null exception, right? So what to do? To allow nulls, you can declare a variable as a nullable string by writing a question mark after the data type. So by writing a question mark over here, we can allow this variable to have a null value. As you can see that we can provide a null value, and we have successfully made variable a as a nullable. Moving ahead, classes. The class declaration consists of the class name parameters, primary constructor, and the class body surrounded by curly braces. Both the header and the body are optional. If the class has no body, curly braces can be omitted. And here classes are pretty much the same as in Java. But here you can see that we do not need to make any constructors over here, as Kotlin will Kotlin compiler will auto generate our constructors and multiple methods for us, so that the developer don't have to waste time. Inheritance. Kotlin classes are final by default. So if you want to allow the class to be inherited, mark that class with the open modifier. So here you can see that we have marked this class as open modifier because we want the dog class to be inherited by the Yorkshire class. The same goes with the functions, right? So if we want this function to be overridden by the Yorkshire class, then we will have to mark that function with the open modifier. Now by this we come to the end of the basics of our Kotlin. Now we'll move ahead with the control flow in Kotlin. So first one is when. When defines a conditional expression with multiple branches. It is similar to the switch statement in Java. When matches its argument against all the branches sequentially until some branch condition is satisfied. Let's see this with an example. Let's create a variable x and let's give it a value. Now we'll pass x to the when statement, and now here if you know about switch cases in Java or C languages, you know that we have a default case in those languages. So similarly we have an else case in Kotlin. So basically what else does is it will if none of the above conditions are satisfied, it will simply go to the else case and it will execute those conditions. So we will simply print, let's say, none over here. So now if we run this code, it should print 2. So see, it prints 2. So now let's say, what if we put 6 over here, right? So 6 is not there in above 3 conditions, so it will go in default else case. Let's see that. Yes, it does go to the default else case and it prints none. Now back to the PPT. Next up is for loop. Well, the for loop iterates through anything that provides an iterator. So here in this example, we are iterating over a list of cakes. We can also iterate over a string. As you know, we discussed previously that string can also be treated as character arrays. So in theory, we can iterate over strings, right? So let's check it out by going to playground. Let's create a variable string and give it a value. Right, and we'll create a for loop. So this should print every character of our string in separate lines. Let's check it out. Well, it does. It does print the every character of our string in separate lines. That means string can be treated as character array. Heading back to our slides. Now while loop checks the condition and if it's satisfied, executes the body and returns the condition check. This again is similar to most of the other languages. There is nothing different in Kotlin. Conditionals. Well, conditionals are also the same as the most other languages. Here a condition is passed to the if statement, and if the condition is satisfied, the true block is ran. If it's not satisfied, the else block is ran. We can also put else if statements in between. But the main difference is that we do not have a ternary operator in Kotlin, right? So how do we get our way around if we do not have a ternary operator? Let's see this with an example. Let's create a function to calculate max. We will pass two parameters of type integer and we'll equate it to the if statement, right? So if a is greater than b, we'll give a, else b, right? So now we'll just print the max value. Let's pass minus 99 and let's say 6, right? So this should basically print 6. Yes, it does print 6. So now those of you who don't know what are ternary operators, so basically ternary operators in Java, we use it like this. If a greater than b, then a, else b. So these are the ternary operators. This is the ternary operator, right? Let's get back to our PPT. Ranges. Well, there is a set of tools for defining ranges in Kotlin. So the best way to make you understand this is by writing a code. Let's remove this and let's write an example code. Let's create a for loop for x in, let's say 0 to 3, right? We'll print x. Let's create another for loop for x in 0 to 4 with step of 2. We'll create one more for loop for x in 0 until 3. Right, and now one last for loop, well, for x in 3 down to 0, and we'll print x. Now let's see what this code does, right? So this double dot is the basic operator for ranges function. What this does is it will print a range from 0 to 3 inclusive of 0 and 3 over here in 0 to 4 but step of 2. So basically this will print from 0 to 4, but it will skip alternate characters. It will print 0 and then it will print 2, then 4, like that. Over here 0 until 3, it's nothing but it will print from 0 to 3, but it will omit out 3. It won't include 3. And in this one 3 down to 0, it will basically print 0 to 3 but in reverse order, right? So let's run this and check. Yes, so as you can see that 0 to 3 inclusive range of 0 and 3, then it's 0 to 4, but it will skip every alternate characters. Then it's 0 to 3, but it will omit out the 3, it won't include 3, and then it's 3 to 0, right? Well, character ranges are also supported in Kotlin, so let's check an example for that too, right? Let's say for x in a to, let's say d, right? So we'll print x, then we'll do for x in, let's say z to s, but it will be a step of 2. Right, so now let's run this. My bad. I will have to put a down to over here. Yes, so here you can see that it this for loop prints a to d inclusive of a and d, and this for loop will print z to s, and it will skip every alternate character, right? But ranges are not only useful in for loops, but they are also useful in if statements. So let's take an example with if statement also. So let's create a variable, let's say x, and set it to 2. Now if you want to check, like let's say if x is in range 1 to 5, right? So if you want to check if x is in range of 1 to 5, and let's print yes, else will print no, right? Now let's run this. You can see that x is in range of 1 to 5, so it will print yes. Okay, moving forward. So now we have completed the control flow, the basic control flow of the Kotlin language, which are the most used ones. So now we will head over to the special classes. Well, so the first up is data classes. Data class makes it easy to create classes that are used to store values. Such classes are automatically provided with methods for copying, getting a string representation, and using instances in collections. You can override these methods with your implementation in the class declaration. Now let's understand data class with an example. Yeah, let's create a data class. Yeah, also data class, we have to provide a modifier of data in front of the class for data classes. So now we'll name it person, and let's take name input of type string, and let's take an id also, id of type int, right? Now we will create two instances of that class. So this is p1 person, will provide name, and let's give id of 214. I'll give p2 person, and let's give him id of 175, right? So now let's print something if p1 equals p2. So over here, as you can see that we haven't specified any equals method inside our data class, but as Kotlin is smart enough to auto generate all these methods for us, we do not need to create those methods, right? So if we print this, it should print false, right? Well, it does print false. Well, but here you can see that both the name and id are compulsory parameters. But what if we want to make some properties to be optional, that we can just specify then we can just specify them inside the class body, right? So let's do this. Let's cut this one out, right, and we'll initialize it to 0. So now there is no need to pass the id parameter over here, but what we'll do is I don't want to set an id for p1, but I want to set an id for p2, right? So I'll do p2.id equals to 175, right? So now over here, let's print p1.id, and let's print p2.id, right? And run this code. My bad. We'll have to make this var, because now we'll be changing it with this one, right? So as you can see that if the p1's as I haven't set the p1's id, it will be defaulted to 0, and I have set p2's id, so it is 175 over here, right? So the next up is enum. An enum is a special class that represents a group of constants which are unchangeable variables like final variables, right? Unlike Java enums, Kotlin enums are classes, right? So let's see, why do we use enums? Well, enums are used when we know all the possible values at the compile time, such as choices on a menu, rounding modes, or command line flags, etc. It is not necessary that set of constant is a enum type stay fixed for all time, right? So now we have completed the most common special classes of the Kotlin, and we will move forward to the collections. Let's see our first collection. So first one is list. A list is an ordered collection of items. So unlike arrays, we can also put items on different data types in the same list. In Kotlin, lists can be either mutable or immutable. For list creation, we use the standard library functions list of for creation, list of for read-only list, and mutable list of for mutable list, right? So here you can see that we have defined mutable list of, so that we are able to add 5 to that list. But what if let's see this with an example, right? So now we'll create a variable, let's say list equals to list of 1 2 3 and 4, and lst dot add 5, right? And now we'll create another variable, list1 is equals to mutable list of 4, right? And lst1 dot add 5, and we'll just print lst1, right? So now as this is a immutable list, we cannot add 5 over here, so this should throw an exception. Well, it does, right? So we cannot modify this list after creating it. So let's check this. So here you can see that the 5 is added to our list 1, and the list 4 is also printed, right? Moving ahead to sets. Set is a collection of unique elements. It reflects the mathematical abstraction of set, which is a group of objects without or repetitions. For creating sets, there are functions very similar to that of list, which is set of and mutable set of, right? So let's see sets with an example. Let's say let's make it set of, and let's make this mutable set of, right? So now let's put another 2 over here. So we have one repeating 2 over here, and let's say we have a 5 over here, and the 3 is repeated also, and also the 3 is repeated, right? So now they should only print the unique characters of both the lists, both the sets. So as you can see here, the second 2 is omitted because it is repeated, and over here the second 3 and the second 5 both are omitted as they are repeated. So set will only return the unique values present inside it, right? Moving on to maps. Map is a collection of key and value pairs where each key is unique and is used to retrieve the corresponding value. For creating maps, we will again use the similar functions as that in list and sets, which is map of and mutable map of. Maps are useful for storing logical connections between objects. Let's say, for example, an employee's ID and their position, right? So over here you can see that this is the key and this is the value, this is the key, and this is the value, right? So all the keys of our map can be accessed by dot keys function, and all the values can be accessed by dot values function. Moving on to filter. Well, filtering is one of the most popular tasks in collection processing. In Kotlin, filtering conditions are defined by lambda functions that can take a collection element and return a boolean value, right? So let's understand this with an example, right? So let's create a variable list and create a list of let's say -3, -2, -1, 0, 1, 2, and 3, right? So now we'll make another list, but it will be it will only contain the positive values of the list, right? So what we'll do is we'll do st.filter, right? And we'll just do it greater than 0, and while negative is lst dot filter where it is less than 0, right? Now let's print all three values. So now let's run our code. So as you can see here, this was our original list, this is our positive list, and this is our negative list, right? So you might be wondering what is it, right? It is just a part of the lambda function. Filter is a lambda function, so it is a variable that is provided by filter itself, right? So now we have completed the collections part. Now we will move forward to the scope functions. Well, the Kotlin standard library function let can be used for scoping and null checks. Let takes the object it is invoked upon as the parameter and returns the result of the lambda expression. Kotlin let is a scoping function wherein the variable declared inside the expression cannot be used outside the declaration, right? So let's check it out with an example. We'll create a variable of str of type string, and we'll set it to, let's say, hello world, right? Now we'll say, okay, let's make string nullable, right? So let's say if we want to if the string is not null, we want a code block to run, right? So we'll do if str is not null, then we'll let, and then we'll be like let's print str itself, right? We'll print str itself. Now let's run our code. So it prints hello world, right? Because it's not null. So now what if I put let's say str equals to null, right? So now if now str is null, so this code block should never run, right? So there should be nothing printed over here, and it should close. My bad, this should be of type var. Let's put null over here. So as you can see that if I am making this variable null, it won't run this statement. But as you can now you can see that here we can it will run this, it will print this one, but it won't print null over here. Let's see. As you can see, it will print the it will completely skip this block, right? Moving on to width. which is recommended for calling functions on the context object without providing the lambda result. In the code, we can understand the with as let's say with this object you can do the following, right? You see, with this object we can do the following. So you can understand with like that. Moving forward, apply, right? So apply is used for the code blocks that don't return a value and mainly operate on the members of the receiver object. The common case for the apply is object configuration. Such calls can be read as apply the following statements to the object, right? See, all these variables we have already initialized it, so they are not the, it's okay if we don't pass the arguments, right? So we can just use instead of like doing let's say adam dot age equals to blah blah blah, we can just use dot apply over here and it will print this, right? Let's see this with an example. Let's create a data class person with let's say name, with a variable name of type string, with a variable age, let's say int, right? So we'll initialize it to 0, right? So here let's create var p1 is equals to person. Let's give him a name Syed and dot apply, and we'll put age equals to, let's say, 19, right? Now let's print p1. Let's keep it var. So as you can see that age equals to 19 is applied over here and size is the name, right? So yeah, this brings us to the end of our session. You can connect with me on the LinkedIn. You can hit me up anytime on LinkedIn regarding Kotlin or Android development. I'll always be open to communication. You can also follow ISTE-VIT. These are the different handles we have. We will be having many more sessions like these. So stay updated by on our following handles, and the attendance form will be shared in the chat box. So do fill it out. Like, share, and subscribe to ISTE-VIT. And thank you so much for coming to this session.